So welcome to lab 3, and in lab 3 we will be focusing on 3 topics: standard deviation, normal distribution, and the empirical rule of 68, 95 and 98. So the whole goal of this 10 chapters lab is to calculate probability using normal distribution. Now before we start with these chapters, let us first finish the homework which was given in lab 2. In that sample example, I had said to calculate the spread using range. So let's first try to calculate the spread using range, and let us understand the issues associated with the same and how standard deviation can help to resolve the same. So now let us go ahead and calculate range 1. So for range 1, we need to first calculate max of it. We also need to calculate mean of it. Then we have range 2, which has max of it and a mean of it, right? So first let us go ahead and calculate the max and the mean. So I'll just say here, this is max. And so now here the range 1 will be 300 minus the mean, and range 2 would be 250 minus this, right? Now looking at this values of the ranges here, you can probably say that this is having a high spread. That's what we can conclude, right? But this conclusion is completely wrong. If you look at data 1, if you look at the difference of values between the record sets of data 1, you can see here this is 5, 10, 15. So it is only 5 values out here. At the down, you can see there are 10 values as well. But here, if you see overall, the spread is quite less between the intermittent values or the values which are in between. Now look at the the spread here, the differences here, like 10, 50, and this is 4 times 200, and then again 50 out here. So this is actually having a high spread. Now what happens with max and mean is it only takes the extreme nodes. It only considers the extreme nodes. It leaves out, the intermittent spread. So because of that, range probably sometimes is not a very good calculator for calculating spread. So for that, we have to use something called as standard deviation. Standard deviation is a value, or it's a quantity which expresses how much the members of a group differ from the mean value of the group. So to calculate standard deviation, you can use the standard deviation formula of Excel. So I can say standard deviation and I can give data 1. So this is the standard deviation of data 1, right? Let us go ahead and insert a row here, or we can say shift cells down, right? Now let's calculate standard deviation for the range 2, for the data set 2. So again, standard deviation, and there it is, and here it is. Now please note that I'm not explaining you how to calculate standard deviation. You can see on the right side of the screen, I have flashed how the standard deviation is calculated. But as I've said in the start of the lecture, try to apply maths and don't try to solve maths. So try to get the gist of what is standard deviation and try to interpret the value. So you can see now here, this is great. Standard deviation here is 92, and here the standard deviation is 115. Now more the standard deviation, that means, the values are more spread out. They are more away from the mean. So when you say standard deviation 115, this has more spread than standard deviation 92. It is very unfair to compare data sets like this, but at this moment, by looking at the absolute values, we can say that this standard deviation is higher than this, so the spread of this is higher than this, right? So you can see now, by using the range, I made a mistake, right? Because of the max and the mean value. But by using standard deviation, now this is looking more appropriate. So henceforth, in the entire class, whenever I say I want to calculate the spread, I will be using standard deviation more rather than the range. So good. So standard deviation tells that how much are the values away from the mean, and it's one of the best ways to calculate the amount of spread. If you notice in the previous lab, that is lab 2, and in this lab, that is lab 3, we are working on one goal, only on one goal, trying to figure out how much data is away or near from the mean in a given data set. So all those statistics like range, median, standard deviation, plotting of the plotter chart was to figure out how much data is away from the mean, or in other words we can say how much data is concentrated around the mean, or let us speak in the language of the statisticians, how much is the data distributed around the mean. Data distribution. The most common distribution pattern for almost all the data is normal distribution. It's termed as normal distribution because this distribution is natural in nature. Normal distribution forms a bell curve, wherein the left and the right of the bell curve has less distributed data, and in the middle is where we have the most data. The center is where we have mean, median and mode. In a perfect bell curve, mean is equal to median is equal to mode. Let's take an example of a student's marks distribution in a class. It follows a perfect normal distribution. You will find very less students who have failed or not performing. You will have very less students who are exceptionals, and most of the students will actually score average marks. This is true for almost all the data you find around you. That's why sometimes mathematicians say that normal distribution is more of a nature's way of arranging data, or nature's law of arranging data. So you will have less amount of people who are underweight, less amount of people who are overweight, and normally people will be of normal weight. You will have less amount of people who are short, less amount of people who are tall, but most of them will be of a normal height. You will have less poor and less rich people, but most of them will be a middle class, right? So every data what you find around you follows this nature's law, that is nature's law of distribution, that is normal distribution. So now let us go ahead and plot the bell curve using the normal distribution. So you can see that we have data out here. This data is like sequential, data is like 1 to 50. And now the first thing for normal distribution you need is, to calculate a normal distribution, you need the mean and you need the standard deviation. So you can see here we have calculated the mean and standard deviation, and here is the sequential data what you see out here. So now here we will go and we will say normal dot distribution. So I'll take the value here. I will take the mean value. So normal distribution needs the value on which we want to calculate normal distribution. We need the mean, we need the standard deviation, and we need that it is cumulative or not, right? So cumulative means we do not want to add up, we just want the individual values. So there it is. Now only the A1, A2, A3 will change, but other things will remain the same. So let us go ahead and put a dollar sign out here, $E, $3, and let us run this formula on all the values. So you can see now this is the normal distribution which is calculated for the data. Now in order to see the graph, the bell curve, we need to go and plot this normal distribution. So let us go ahead and click on insert. Let us click on this data and let us go to the chart, and there you can see this chart here which is of a normal distribution icon. So click on that and there you can see the normal distribution is plotted. Also you can see that I'm flashing up the formula at the right hand side where I'm showing that how normal distribution you can calculate manually. But as I've suggested that please do not try to calculate the formulas, try to apply them, right? So you can see now at the left hand side is our normal distribution, and down below we have our actual data. So you can see now this 10 is corresponding to 0.015. So you can see 10 is corresponding to 0.015. 20 is corresponding to 0.025. So 20 is corresponding to 0.025. It's here, you can see I've highlighted. So you can see that the graph has been plotted by using the normal distribution and the actual data. One of the concepts which is discussed a lot in normal distribution is one standard deviation, second standard deviation, and third standard deviation. All these three things divide the bell curve into three ranges of data, and each range says how far is the data away from the mean. The more the data is away from the mean, the less is the probability of its occurrence. The more the data is near to the mean, the more the probability of its occurrence. So let's go ahead and see that how we can calculate the first standard deviation, the second one, and the third one. So remember, it's a range of data. So we will have a max and a mean. I'll say mean and a max range, as an output here. So the first standard deviation says that from the mean, the minimum is mean minus the standard deviation. So it is mean minus the standard deviation. Mean, I'm sorry, what am I doing? Mean minus the standard deviation. Let us go ahead and put a dollar sign here because we're going to go and use this again and again, right? And the max says the mean plus the standard deviation. So this is the first standard deviation. So you can see the range of the first standard deviation is 10.9, approximately 11 to 40, right? Now for the second standard deviation, we need to go and say the mean and the max, the formula remains the same, but the only thing what changes here is this is 2 into the standard deviation. So the formula is the minimum range is mean minus 2 standard deviation, and here it is mean plus 2 standard deviation. So in the same way for the third it is 3 standard deviation. So the minimum is 3 and the maximum also is 3. So you can see the first standard deviation is mean plus minus standard deviation. The second one is mean plus minus 2 into standard deviation, right? And the third one is mean plus minus 3 standard deviation. Connected to normal distribution, we also need to know something called as the empirical rule. Empirical means by past history and observation, it's noted that the first standard deviation forms 68% of your data. The second standard deviation forms 95% and the third one 99%. To be very specific, it is 68.27%, then 95.45% and 99.73%. So empirical rule defines the actual values, actual percentage under which this 3 normal distributions will lie, or the 3 standard deviations will lie. So you can see here that this is saying 10 to 40. So this will form the 68% of the data. This will form 95%. The last one will form 99%. Let's try to visually analyze, or I'll say visually see, how the 68, 95 and 99 data distribution looks on the bell curve. So you can see this is the bell curve, and down below you can see the first standard deviation, which is from -1 to +1, the second standard deviation, which is -2 to +2, and third standard deviation, which is -3 to +3. So the first standard deviation has 68%. The second standard deviation from -2 to +2 is 95%, and the last one is 99%. Now each one of these standard deviation actually tells you that how away they are from the mean. So if you say 68%, then 34% falls on the left side of the mean, and the other 34% falls on the right side of the mean. In the same way, when you say 95%, so 95 divided by 2 will fall on the left of the mean, and 95 by 2 will fall on the right of the mean, and so on. Now you can see here, for example, if this is 34% and this is 34%, that means this is 68% and this is 95%, then you can say that this third section is 13.5%. So 13.5%. Why? So 95 minus 68, look at it, 95 minus 68, which is 27. Again, we said on the left side of the bell curve 50% will lie, and on the right side of the bell curve 50% will lie. So if I divide by 2, this is 13.5. So this section out here is 13.5% here and 13.5% here. I will tell you that why I'm discussing this, the percentage distribution of smaller sections here. In the same way, you can see 25% is calculated. So if you say 99 minus 5, and then so 99 minus 5, whatever we come out with, so the remaining amount 50% split here and 50% split here. So this is how the data distribution of 68, 95 and 99 looks like. So now let's try to see that how the current calculation which we have done on this sequential number, how does it look as a plot visually on the bell curve. So if you remember, we had calculated the first standard deviation is from 11 to 40, the second from -3 to 54, and third from -18 to 69. So let us go and see visually how it looks like. Visually it looks something like this. You can see at the left hand side I have pasted the same calculations of the Excel so that we can see it easily on the left hand side. So the first standard deviation is from 10.9, that is 11 to 40. So this is the first standard deviation, which is 68%, 34% on the left side and 34% on the right side. The second one is from -3 to 54. So -3 to 54, 95%, with 13.5% falling on these areas. And then we have the -18 to 69, which is 99%, right? So this is how our current values looks over the distribution. So now let's answer the most important question. So what are we achieving by understanding this bell curve, by understanding the distribution, by understanding 68, 95, 99? What have we achieved finally? We have achieved that now we can define the percentage of probability of a value which will occur. So basically we can now apply probability and define that what is the percentage that the value can occur in that distribution. For example, now look at this chart out here. So you can see at the top I have put a question. So what is the probability of getting a value above 25? 50%. What is the probability of getting value below 25? 50%. Now let's look at the other kind of question we can answer. What is the probability of the value 20 occurring, right? So remember we had the first standard deviation which was from 10 to 40, and this was 68%, so this is 34%, and the 20 value lies between 10 to 25, right out here. So the probability of the value 20 to be occurring is 34%. Let's look at the other question we can answer here. What is the probability of the range 40 to 60 occurring? Okay, 40 to 60. So 40 to 60 lies at the right of the bell curve. Remember, 40 to 60. That is between 40 to 69. This 40 to 60 value will lie. So 13.5%. This section was, and 2.5%. So 13.5 plus 2.5 is 16%. So the probability of range 40 to 60 happening is 16%. So now you can see, once you know the distribution, it is very easy to predict the probability of the occurrence of that value. So that brings us to the end of this session. Now there are three things at the end of the session. The first one is this Excel sheet on which I was practicing. This Excel sheet you can download and you can have a look at how I have done the calculations. The second one is I will give you a practice sheet. So I want you to open the practice sheet, and in the practice sheet I have given a sample data. I want you to go ahead and try to plot the normal distribution for it. And the last one is I will flash up some questions at the end. Try to please revise those questions and see that what you learned in this class. Thank you very much. Welcome to lab 4, and in this lab we will focus on Z-score, Z-score and Z-score. Z-score is the final essence and truth of normal distribution, empirical rule, standard deviation and so on. So whatever we have discussed till now, this is the final thing we will use to get answers of our probability in the normal distribution plot. So let's take lab 3 Excel practice sheet and let's first plot the normal distribution graph, and then we will calculate Z-score from the same. So let's get started. So this is my lab 3 Excel sheet out here. So let us go ahead and plot the normal distribution. So you can see here already I have calculated the average, I have calculated the standard deviation, and also I have calculated the normal distribution. So this already we have covered in the previous lab. So let us go ahead and quickly plot this. So I'm going to go and select this and I will click on insert, and let us quickly try to plot this chart. So now there it is. You can see the chart has been plotted, and the chart does not look smooth like the standard distribution or the normal distribution chart, what we have seen previously. So it is not that perfect bell curve, right? But it is a bell curve, right? So guys, remember that when you are working with practical data, you won't really find a perfect normal distribution. when you find something like this, this is also normal distribution. For example, let me try to go and fix some things out here. For example, I can see out here there are a lot of duplicate values, so because of these duplicate values I'm getting these straight lines, right? So let us try to correct this normal distribution a bit, and let us see that if we can come nearby to that normal distribution. So I'm going to go here, and first thing I will try to remove the duplicates from here. So I'll say data, and let us say remove duplicates. So I'll say continue with the current selection. I'll say remove duplicates. So let's try to remove some duplicates. 118 duplicates have been removed. Oh, what is that? Hang on. Remove duplicates. Yes, I know. And I'll just say okay, 118 duplicates. Yeah, so that looks good. You can see now. So there it is. It's still not looking good. Let's remove all these white spaces out here. You can see from 20 to 160 we are literally not doing anything. So let's go to the properties. So I'm going to go to the format the chart area. So in this, let us take the axis, the down axis, and let us see that if we can let's not go to 160. Let us try to make it like I can see 20 as the max. So let's do it 20 and tab out. Oh, there it is. Now you can see things are looking better. I again say that this is not a perfect bell curve, but yes, it is normal distribution, right? And remember that if I keep on adding more data, if I had a lot of more data, then probably this would have been approximated to a bell curve, right? So at this moment, this is a bell curve, and let us try to go ahead and calculate the first standard distribution and the second standard distribution and the third standard distribution, right? So I'm going to go here and calculate the first standard distribution, the second, and the third. So let's do this. Standard distribution. So there it is. I have calculated the first standard deviation, the second standard deviation, and the third. So what I did is I paused the video and I did these calculations at the back end because these calculations have already been explained in the previous part of the videos. So I will not be revisiting it. But now let's think, we have done so much, but what does the end user really want? The end user wants only two things. He needs one simple text box or simple place where he can go and put the sales amount. So this is where he can go and say, okay, he will put the sales amount 50, and somewhere here he should show the probability saying okay 90%, right? So the end user wants that. He wants a place where you can go and say, okay, can you tell me that if I think that my sales has to be 150, what is my probability? So your probability is 20%. Right? So that's what the end user wants. So and end users won't go and look into this bell curve and then think about those empirical rules. It is so difficult, right? That's where we IT people should come in and we should automate it. So in order to achieve the same, we have to use something called as the Z-score. What the Z-score says is, the Z-score says that on which standard deviation you are currently on, right? So I'm going to go and apply Z-score now. So Z-score just says that on which standard deviation you are. Are you on first standard deviation or are you on second standard deviation? So in order to get the Z-score, we have to use the standardized formula. Again, like at the right hand side, I am flashing up the Z-score calculation. So I will not be explaining you how Z-score is calculated. You can see that on the screen. But at this moment, I will be using Excel to calculate the Z-score. So to calculate the Z-score, we have to use something called as standardized. So I'm going to go and say, okay, take this is 150, that X is 150. We need to have the mean. We already have the mean. And then we need to get the standard deviation, which we already have, right? So now if you look at 150, 150 goes into the third standard deviation. So you can see here, it goes on the right side of the curve. You can see in the third standard deviation, it is showing here 150, 145 as the max. So it is going above that. So you can see it is showing 3.16. That means it is saying that it is lying on the right side of the extreme of the bell curve, right? So it's lying. So if you really ask me, when you say 3.165, it is lying somewhere here, right? Somewhere down. Now let us go ahead and put, let's say 32. You can see it is -1, right? So -1 means it is lying somewhere in this first standard deviation out here. So if I go and put here let's say if I go more down, if I, or let's say if I put now the average, the single center point, so you can see now it is 60. So okay, 32 and 88, so somewhere between 70, I'll say, must be 80 or must be 75. So 75 is here on the center of here, so this is 75 out here. So you can see 32 and 88, it's 75.50, right? So basically what this z-score says is, it just says that on which standard deviation at this moment you are on. Are you on the first standard deviation? Are you on the second one? Are you on the third one? It also tells you that are you on the left of the bell curve or are you on the right of the bell curve? So in other words, if I go and put here like 4, it says me, oh, you are on the left of the bell curve. But if I go and put here 100, it says, oh, you are on the right of the bell curve and you are so much deviations away, right? So now with this, now that we know that we have got the z-score, so using this z-score, now we can calculate the actual probability. So now what we really need to do is we need to take this z value and we need to calculate the probability. That's what the final goal is. Now it's not so easy, because if you see, this whole bell curve is divided, with the empirical rule, that is your 60 and 95 and 98. So if you want to really do the calculation, then you need to follow that logic, right? So what I'm going to do is I'm going to go and use a z-score table here. Now this z-score table I have taken from online, but if you are using Python and R, they already have ready-made ways of getting this z-score table, right? And at this moment we are in Excel. So in Excel we do not have really a way of doing calculation of z-score table. We can do it, but let me not get into that, because in Python and R we have better way of getting a z-score table. So in this z-score table is nothing but it is a value which is, it is a range of values between -3 to +3. So if you see here, this is -3 values. As you scroll below, you will see that it also then starts with a plus value. So you can see these are all plus values, right? And somewhere in between, so if you see the value like 0, right, it is 50%, right? So that's where our mean is, right? So what I will do is I will just go ahead and do a VLOOKUP of this score into this Excel sheet out here, right? So let us do that. So I'm going to go here and do a VLOOKUP. So I'll say here VLOOKUP of this value where into this table array. So I'm going to go and use this table array, and I will say, and what is the final output I want? I want the final output is this call index. So it is 2, right? And I want it to have an approximate match. So it is okay that if it is 0.081, it should be able to look at 0.08, right? So I want to have an approximate match, and there it is. So you can see now when I'm for this value 32, it is showing me 0.15. We can convert this to a percent as well. So we can just say into 100, that's a percentage. So you can see here now when I say, let us say when I say 60 now, if you remember in the previous part of the video, when I said 60, it was not giving me the exact value. But now when I say 60, it is giving me approximately 50%. So if I say 60.61, so that is exactly 50%, because now, we are following the Z table, right? The Z score table. So you can see here for 32, we have 15%. For 88, we have 16%. So now when I put the sales amount by using the Z lookup, I am able to get the exact percentage of probability. So that brings us to the end of this lab, that is lab 4. I would request you to go through this Excel sheet, go through the Z-score tables, and at the end of this lab, I'm flashing some questions. Please try to answer them. So now the next lab, that is lab 5, is dedicated to binomial distribution. So keep watching the videos and happy learning. Thank you very much.